An aqueous solution Y is known to contain one type of group 2 metal ion. Okay, so that's given us a clue, so something from group 2, and one type of negative ion. Aqueous solutions of sulfuric acid and magnesium nitrate are added to separate solutions of Y. Now we're being shown white precipitate, so this is a question that is linking us to required practical 4, testing ions in solution. So we know we're looking for a group 2 metal ion, and the tests for group 2 metal ions are if we add anything containing sulfate ions, we'll be able to identify barium ions, and if we add any hydroxide ions, that will allow us to identify magnesium ions. And then we've got a test for negative ion, so we're using that knowledge from group 2 and are testing for ions to try and answer this question. So sulfuric acid is added. Now sulfuric acid contains acid, H plus ions, and sulfate ions. Sulfate ions to test for barium ions, and we'll get a white precipitate. Acid is a test for carbonate, a negative ion carbonate, but that would give us effervescence. Now there's no effervescence here. This white precipitate must be barium sulfate because we've formed it with sulfate ions and acid wouldn't give us that white precipitate. And then the next test, we've got magnesium ions and nitrate ions in magnesium nitrate. Now nitrate ions don't do anything, so magnesium ions is a test for hydroxide because it gives us sparingly soluble magnesium hydroxide. So that's what that white precipitate must be. So it says, suggest the identity of the group 2 metal ion present in Y. The metal ion that we must have had present must have been barium 2+, because that would give us a white precipitate with sulfate ions. And then it says ionic equation including state symbols. So the barium ions, which were in solution, reacted, because it was a solution of Y, reacted with the sulfate ions, opposite charges attract, from sulfuric acid, to give us the solid white precipitate of insoluble barium sulfate. Then it asks us to find the negative ion in Y, and it says write in the ionic equation including state symbols. Now because in the second reaction we were using magnesium ions to make magnesium hydroxide, the negative ion must be hydroxide ions, again with state symbols. The magnesium ions from magnesium nitrate solution reacted with the hydroxide ions in Y. Now looking at the charges and the formula of magnesium hydroxide, we know we must have to have a 2 there. And we get magnesium sparingly soluble hydroxide, so that's a solid.